Welcome to this lecture on the emergence and spread of antibiotic-resistant bacteria. This lecture explains how antibiotic-resistant bacteria can increase in numbers when exposed to an antibiotic, and how they can spread between people, animals, in society and across the world. Antibiotic resistance is a natural process. Mutations and other changes in the bacterial DNA happen continuously, and by chance, some bacteria will change so that they are able to survive antibiotic exposure. Here you see a typical bacterial population. The majority of the bacteria are sensitive to antibiotics, but there may be one or a few antibiotic-resistant bacteria present. If the bacteria are now treated with an antibiotic, most will be killed or at least stop growing, but the resistant bacteria will survive. As long as the antibiotic is there, the resistant bacteria have no competition and can increase in number. The end result is a bacterial population consisting of mainly resistant bacteria. If we then look at what happens inside the human body when we have a bacterial infection, we see a similar pattern. Any resistant bacterium that is present will survive antibiotic treatment and can start to increase in number. This can ultimately lead to treatment failure, although this depends on many factors, such as how well your own immune system can take care of the infection. At the same time, an antibiotic treatment will also have an effect on the bacteria that normally lives in the body, the so-called normal flora, that have nothing to do with the infection in question. Instead, these bacteria often have beneficial functions for humans. They can, for example, degrade food or protect against pathogens. Resistance can also develop in the normal flora, and similar to at the site of infection, the antibiotic will allow these resistant bacteria to increase in numbers. This could become a problem later in life if the resistance spreads to bacteria that can cause disease, or if bacteria from the normal flora cause an infection. Once the resistant bacteria increase in number, the risk for spread increases. This infographic by the European Centre for Disease Prevention and Control, ECDC, explains how resistant bacteria can spread. Point 1 to 3 describes the role of animal farming. Animals may be given antibiotics to treat or prevent disease, or to make them grow faster, and they can therefore carry antibiotic-resistant bacteria. Vegetables may be contaminated with antibiotic-resistant bacteria from animal manure used as fertilizers. Antibiotic-resistant bacteria can then spread to humans through food and direct contact with animals. Trade with animals, meat, vegetables, and other goods can further disseminate the resistant bacteria across the world. Point 4 describes spread within the community. Humans sometimes receive antibiotics prescribed to treat infections, or sometimes self-medicate with antibiotics, particularly in settings where antibiotics are easily available. However, bacteria develop resistance to antibiotics as a natural, adaptive reaction. Antibiotic-resistant bacteria can then spread from the treated patient to other persons. Point 5 and 6 describe spread in healthcare settings. Humans may receive antibiotics in hospitals and then carry antibiotic-resistant bacteria. These can spread to other patients via unclean hands or contaminated objects. Patients who may be carrying antibiotic-resistant bacteria will ultimately be sent home and can spread these resistant bacteria to other persons. Point 7 and 8 highlights the role of international travel. Travelers requiring hospital care while visiting a country with high prevalence of antibiotic resistance may return with antibiotic-resistant bacteria. Even when not in contact with healthcare, travelers often become carriers and import resistant bacteria acquired during travel. So, in conclusion, antibiotic resistance will eventually develop to any antibiotic. The more antibiotics we use, the more likely it is that resistance is maintained among the bacteria. The resistant bacteria can then spread between people, animals, and in the environment via multiple routes. It is unclear exactly how much each of these routes contributes to this process, but all of them play a role in the worldwide emergence and spread of antibiotic-resistant bacteria.